Hi there students, and welcome to lesson 4 on this topic of quadratic equations and their graphs. Now, during this lesson we are going to draw an accurate graph of a quadratic equation. Now, in order to draw an accurate graph of a quadratic equation, there are 4 things you need to know about the graph. The first thing is you need to know the general shape of the graph. And remember, with quadratic equations there are only 2 possible general shapes: an upright parabola, smiley face curve, or an inverted parabola, a sad face curve. So that's the first thing. Second thing is you need to know the y-intercept for the graph of the quadratic equation. The y-intercept is the point where the graph cuts through the vertical axis or the y-axis. The third thing is you need to know the x-intercept or intercepts of the quadratic equation graph, and the x-intercept or intercepts are the x values where the quadratic equation graph cuts through the x-axis. The x-axis being the horizontal axis. Now, remember, quadratic equation graphs, there are 3 possibilities for the number of x-intercepts. Some quadratic equation graphs have no x-intercepts, some have only 1 x-intercept, some have 2 x-intercepts. Alright, so far we've got the shape. You've got to decide the general shape. That's the first thing. Second thing is you've got to decide the y-intercept for the graph. Third thing is you've got to work out or decide what the x-intercept or intercepts are for the graph. And the fourth thing, the fourth important feature of a quadratic equation graph or a parabola graph is the turning point. You need to find the exact location of the turning point. Let's have a look at what I've got on the board. So, in this lesson we are going to draw an accurate graph of the following quadratic equation. Y equals x squared minus 4x plus 3. That's the expanded form of the quadratic equation. I've also given it to you in factorised form. The factorised form of the quadratic equation is y equals x minus 1 multiplied by x minus 3. We need to use the factorised form of the quadratic equation to find the x-intercepts of the quadratic equation. Now, with what I've got on the board, I've actually made it a 7-step process. Let's start working through those steps. The first step is decide the shape. What general shape is this quadratic equation graph going to be? Well, remember, there are only 2 possible general shapes: an upright parabola curve or an inverted parabola curve. And to decide which of those 2 possible shapes we're going to end up getting, we look at the sign of the number directly in front of x squared in the expanded form of the quadratic equation. Now, there's no number in front of x squared there. When there's no number in front of a pronumeral in a mathematical expression, the number is actually positive 1. So what did I just say? The number in front of x squared here is actually positive 1. Okay? The sign of the number directly in front of x squared therefore is positive. That means we are going to have an upright parabola curve. So let's put a circle around this choice. Okay, it's going to be that general shape there. An upright parabola curve with a very lowest point on the curve called the minimum turning point. So we've decided the shape. On to the second step, find the y-intercept. Now, to find the y-intercept for the graph of any equation at all in mathematics, this is what you do. You go back to the equation, and wherever there is an x in the equation, you replace x with 0 and solve the resulting equation for y. So to find the y-intercept for the graph of any equation, you replace x with 0 in the equation and solve the resulting equation for y. What happens with this equation here? Okay, find the y-intercept. Okay, what I've done here is I've gone back to the equation here, I've replaced x with 0. Wherever there's an x in the equation, I've replaced it with 0. What final answer do we get? Well, we have 0 squared minus 4 times 0 plus 3. Gives us a final answer of positive 3. So that means the y-intercept, or the value where this quadratic equation graph cuts through the y-axis, is at y equals 3. Let's locate this point on the set. Let's locate that y-intercept, y equals 3, on this set of x, y axes here. We already know Well, we've just found that the y-intercept is y equals 3. We already know that the graph is going to go through that point there on the y-axis at a y value of 3. On to the third step. Find the x-intercept or intercepts. Remember, some quadratic equations have no x-intercepts, some have one x-intercept, some have two x-intercepts. This one, turns out this one has two x-intercepts. Now, to find the x-intercepts for the graph of a quadratic equation, you need to use the factorised form of the quadratic equation. And to find the x-intercept of any mathematical equation at all, this is what you do. You go back to the equation, and wherever there's a y in the equation, you replace y with 0 and solve the resulting equation for x. So what happens here? I've written out the factorised form of the quadratic equation. I've replaced y with 0. The factorised form of the quadratic equation is y equals x minus 1 multiplied by x minus 3. I've replaced y with 0. Now we're left with this equation here to solve. 0 equals x minus 1 multiplied by x minus 3. The first factor is x minus 1. The second factor is x minus 3. Now, when you're going to multiply two factors together to get a final answer of 0, as we're going to get here, one or both of those factors has to equal 0. So, the answers for the x-intercepts will be the x values of the x values which make each factor equal to 0. So, that's how you find the x-intercepts. They will be the x values, or the number values of x, which make each factor equal to 0. What's the number? The first factor is x minus 1. The number value of x which makes this first factor, x minus 1, equal to 0 is positive 1. Because positive 1 minus 1 is 0. The number value of x which makes this second factor, and the second factor is x minus 3, the number value of x which makes the second factor equal to 0 is positive 3, because positive 3 minus 3 equals 0. So the two x-intercepts are positive 1 and positive 3. Let's mark those on our set of x-y axes here. Here's the x-axis, the horizontal axis. We've just determined that the graph of this quadratic equation will cut through the x-axis at an x value of positive 1 and an x value of positive 3. So it's going to cut through there at an x value of 1 and there at an x value of 3. On to the fourth step. Now, we now need to locate the turning point. Now, this is how it works. The fourth step is find the x-coordinate of the turning point. The x-coordinate of the turning point will always be exactly halfway between the two x-intercepts. Alright? Our two x-intercepts are positive 1 and positive 3. What's exactly halfway between positive 1 and positive 3? Well, it's easy on this occasion, isn't it? It's positive 2. So the x-coordinate of the turning point will be x equals positive 2. I've written that there. X subscript TP. TP for turning point. XTP equals positive 2. Now, we need to find the y-coordinate of the turning point. Now, we already know that the x-coordinate of the turning point is 2. To find the y value, which goes with or matches that x value of 2, what we do is we substitute an x value of 2. In other words, we substitute this xtp value into the equation and get an answer for y. So that's what I'm doing here. Fifth, find the y-coordinate of the turning point. Substitute xtp equals 2 into the quadratic equation. So, wherever there's an x in the equation, we replace x with 2. So instead of x squared, we've got 2 squared. Instead of minus 4 times x, we've got minus 4 times 2. What answer do we get? What final answer do we get? 2 squared is 4, minus 4 times 2 is 8, 4 minus 8 is negative 4, then negative 4 plus 3 is negative 1. The y-coordinate of the turning point is negative 1. Now we can write down, in step 6, now we can state the coordinates of the turning point. Okay, the turning point has an x value of 2, comma, a y value of negative 1. So, let's locate the turning point on this set of xy axes here. The turning point, is at 2, negative 1. We go across to 2 and we go down to negative 1, and there's the turning point. I'll put a big blue dot there. Now, we know the shape of the graph is like that. It's a smiley face curve or an upright parabola. We know it's got to go through that point there, that point there. That's the turning point. So that'll be the very lowest point on the graph. And then it goes back up and goes through that x-intercept there of positive 3. So let's draw the graph. Comes down, goes through that y-intercept there, then through that x-intercept, comes down as low as the turning point. The turning point is where it turns around and goes back up again. So it goes back up again and goes through that x-intercept there. There is the graph. There is the graph of the quadratic equation y equals x squared minus 4x plus 3. That concludes lesson 4 on this topic of quadratic equations and graphs. Stay tuned for further lessons on this topic. Thanks for watching. See you next time.